Hello friends, welcome to engineering tutorial. So we'll continue our discussion on projectile motion. So this is another question. So here it has been given that in between two hills of heights 100 meter and 92 meter respectively, there is a valley of breadth 16 meter. If a vehicle jumps from the first hill to the second hill, what must be its minimum horizontal velocity so that it does not fall off into the valley? So let us try to understand this whole situation with the help of a diagram. So we have two hills. This is the top of one hill. This is the valley, and then we have another hill here. Okay, this is the first hill, this is the second hill. The height of the first hill is 100 meters, and the height of the second hill is 92 meters. So as you can see, the second hill is of lower height than the first. A vehicle is trying to jump from one hill to the other. Well, it's a stupid idea, but still in the question it is given, so we'll follow it. So vehicle is trying to jump from the first hill to the second hill with a horizontal velocity. Okay, with a horizontal velocity, we'll keep it ux. So we have to calculate this minimum value of horizontal velocity so that it does not fall off into the valley. It does not fall into the valley, but it crosses and lands onto the next hill. We want this. Okay, we want it to land onto the next hill. So we have to determine the minimum velocity so that it lands on the next hill, the second hill. So here we have to analyze for this projectile motion from hill 1 to hill 2. Let the vehicle, it lands on the second hill. So here the net vertical displacement of the vehicle, that is the difference of heights between the two hills, that is equal to 8 meter. This is the net vertical displacement, which is the height difference between the two hills, 100 minus 92. Okay, that. So here we'll be using the equation of motion, this one, S is equal to ut plus half at square. We'll split it into two parts. First we'll write the y equation. Sy is equal to uyt plus half ayt square. Here there is only horizontal component of the velocity, no vertical velocity, no vertical component. So uy is equal to 0 meter per second. Acceleration due to gravity is acting downwards. So ay is equal to plus g. Okay, ay is equal to plus g. So here another important thing which I missed in the question, that is, here we have to take g, acceleration due to gravity, as 9 meter per second square. It is mentioned in the question, so we have to take that. Okay, so acceleration due to gravity, that is acting in the downward direction. For the downward motion of the vehicle, it supports it, so it is plus 9 meter per second square. So here simply we'll put the values. Here uy is 0, so this whole thing will become 0, and this will be equal to 1/2 9 into t square. Okay, and that is equal to Sy, which is the net vertical displacement, that is equal to the height difference of the two hills, that is equal to 8. That implies T is equal to how much? 2 into 8 by 9 root over, and that is equal to, it is coming 16 by 9, so it will be 4 by 3 seconds. And this is the time of flight of the vehicle. So here, if you use the shortcut or the quick formula, if you remember, time of flight will simply be root over of 2 h height difference hd by g. So we'll get the same result, 4 by 3 seconds. That is the time of flight. So this is taking into account the vertical motion. Now here, in order for the vehicle to safely land on the second hill, the net horizontal distance covered by the vehicle should be greater than this breadth of the valley, which is equal to how much? 16 meters. The valley breadth is 16 meter. Okay, this. The valley breadth is 16 meter. So for the vehicle to safely cross the valley and land on the second hill, the net horizontal displacement or the net displacement along the x-axis, it should be greater than the valley breadth, that is 16 meter. It should exceed that. If it is less than that, then it will fall off into the valley. Okay, this. If it is less than that. If it is greater than this valley breadth, it means it will land on the next hill safely. So this is the condition. The net horizontal displacement, it should be greater than the valley breadth, that is 16 meter. So here we'll be using that. So here Sx, that is the net horizontal displacement, that is equal to the horizontal component of the velocity, that is ux, into time of flight, this. So here we want Sx should be greater than or equal to 16 meter. Okay, so that implies ux tf should be greater than or equal to 16 meter. That implies ux should be greater than or equal to 16 by tf. That implies ux should be greater than or equal to 16 by 4 by 3, and that is equal to how much? 12 meter per second. So it means the horizontal velocity should be greater than or equal to 12 meter per second. It means the minimum velocity, the minimum horizontal velocity, so that the vehicle will safely land on the next hill, that is equal to 12 meter per second. If it is less than this, the vehicle will fall off into the valley. If it is greater than this, then the vehicle will safely land on the hill. And if it is equal to 12 meter per second, then it will just land on the edge of the next hill. So we don't want that. So we want to stay safe. So it should be much greater than 12 meter per second. Okay, so this is the. So here is another question on projectile motion with horizontal projection. It is given that a helicopter is moving with a horizontal velocity u. According to the diagram, it dropped a packet at point A here, and as obvious, it went had projectile motion with horizontal projection, that kind of a trajectory, and it reached point B. So it is asked to find an expression for this distance AB in terms of x and y and whatever other parameters which will be involved. So we have to find an expression. So we solved a similar kind of question, but here there is no inclination angle given, nothing mentioned like that. So we have to use the equations of motion again and find an expression for this distance, or this expression for this distance AB. So let's name it D. Okay, D. So as you can see, we can apply Pythagoras theorem. D is simply x square plus y square, this. Now our objective is to find expressions for x and y. So here again, principle of independence of motion. Here the net horizontal displacement Sx, that is equal to x, and the net vertical displacement Sy, that is equal to y. Okay, and here this u, that is the horizontal projection velocity, it has no vertical component. The initial velocity, it has no vertical component, so uy will be equal to 0 meter per second. Okay, this is ux meter per second, or whatever units it is. So there is nothing mentioned here, so it is simply, let's keep it 0. Nothing is mentioned, so simply 0. Then acceleration due to gravity, it acts downwards, it supports the downward vertical motion of the packet, so it will be plus g. There is no accelerating or decelerating force in the horizontal direction, so ax will be equal to 0 meter per second square. So again, no unit is given, so we can simply keep it as 0. Now first we'll apply the equation Sx is equal to uxt plus 1/2 ax t square. Now ax is equal to 0, so this whole term, it will become 0. So we'll simply have Sx is equal to uxt. So we'll write Sx, that is equal to x is equal to ux, that is equal to u into t. So t is equal to x by u. This is one expression. T is equal to x by u. Next, Sy is equal to uyt plus 1/2 ay t square. Now the initial velocity has no vertical component, so this whole term will become 0. So we'll have Sy, which is equal to y is equal to 1/2 ay, which is equal to g, 1/2 g t square. That implies here t square is equal to 2y by g, or t is equal to root over of 2y by g. So this is another expression for t. Let's name it equation number 2. Now if we compare equation 1 and equation 2, they both represent the same thing, the time of flight. Here t represents the time of flight. So they will be the same whether you do the x component analysis or y component analysis. So that implies x by u implies x by u is equal to root over of 2y by g, or that implies x is equal to u into root over of 2y by g. This. Okay, x is equal to u into root over of 2y by g. Let's name it equation number 3. Now going back to the first part where we expressed the distance AB in terms of root over of x square plus y square, the Pythagoras theorem. So we'll make the substitutions. So here D is equal to root over of x square plus y square. So it is better that we express it in terms of one parameter, x or y. So here x is equal to u into root over of 2y by g, x in terms of y. So we'll keep y as it is and we'll substitute x with this. So that is equal to u root over of 2y by g whole square plus y square. Okay, so this becomes root over of 2y u square by g, okay, plus y square. Okay, or we can write it as root over of 2u square y by g plus y square. Okay, you can take y common also. Y into y plus 2u square by g. Okay, y square plus 2u square y by g. You can also take y common, okay, and express it in this way. So this is the thing. Again, getting an answer with the form of an expression. X, y and the initial velocity u and acceleration due to gravity g. Okay, so this is the thing.